right, so today we're going to learn the third method on how to solve systems of equations. We've done graphing, we've done substitution, now we're going to do what's called elimination. Now, do you guys remember what the whole goal of this solving of systems is? What is the whole entire goal of these? What are we finding? What are we finding when we find the solution? We're not finding a slope. No. What solution? What is a solution? Where the two lines intersect. Good. Where the two lines intersect is our entire goal. We want to find the x-coordinate and the y-coordinate where they intersect. Is that what you said, Nico?
Find the coordinates.
Oh, okay. Where they intersect, correct. Okay. Some people like this method better. This method really works when you have everything lined up correctly. So what I mean by that is if you look at these two equations on letter A, we have 5x minus 6y equals negative 32, and we have 3x plus 6y equals 48. The x's are in line, the y's are in line, our equal signs are in line, and the number without the variables in line. So everything has to be exactly lined up to use elimination. What you're going to be looking for here is you're looking for a situation that looks like this. I want you to look at your y values, your y terms. Your y terms, one of the y coefficients is negative 6. The other coefficient to the y is 6. Negative 6, positive 6. When we add those two numbers together, what do we end up with? 0. And that is our goal, is to find a variable where we have a positive number and a negative number of the same number. We want to look for opposite numbers. So we might look for 10 and negative 10, or 5 and negative 5. But you just want opposite numbers like we have here with negative 6 and positive 6. And what we do is we add the two equations together. So I want you to draw a line under here. We add these two equations together. We're going to add down. We have 5x and 3x. What does that add to get?
2.
Not 2. 8x. So 8x. Now our negative 6y and our positive 6y, what does that add to? 0. That's why we call elimination. That's why it's called elimination, because we're eliminating the y value, or the y variable right now. Equals, so these cancel. Negative 32 plus 48. What do we get there?
12.
Not
16.
16. And then to get x by itself, we divide both sides by 8. So we get x equals 2. So we already know our x-coordinate. See how fast that was? We already know our x-coordinate. Our x-coordinate is 2.
Might do my homework.
We now need to find our y-coordinate. What can I do with this x equals 2 to maybe help us find the y-coordinate? Plug 2 into one of the equations. So we're going to go back, and it's kind of like the same step as substitution. Once we found 1, we were able to go plug back into one of the equations. So we're going to take this x equals 2, and we're going to plug it in. Top or bottom equation? What do you think? Bottom. We'll plug it in right there. Oh, either way, it doesn't matter.
I'll get another question.
Yes?
Are you going to put out a video like you did for the test except for the quiz tomorrow?
No.
What?
Okay, so 3 times x, so we get 3 times x. What was x? X was 2. Okay, so we're replacing x with 2. Plus 6y equals 48. So now we solve this equation. Okay, so we solve this equation. 3 times 2 gives us what?
6.
So we get 6 plus 6y equals 48. Subtract 6 from both sides. So we get 6y equals 42. Divide by 6. So y is 7. So our x-coordinate is 7. And that's our solution. That's where they intersect. Okay, any questions on the first example?
No, ma'am.
Okay. The second letter B here, the second problem we have up here, if you notice, we don't have a situation presenting itself where we have like a positive and negative of the same number, do we? Like over here, we had a negative 6 and a positive 6. Do we have that over here in B? We do not. So here's what we have to make that happen. We have to change one of the equations to help us get that to happen. I want you to focus. I want you to focus on the x terms. I want you to focus on the 2x and the 10x. The bottom one is a 10x, right? It's a positive 10. What would be really nice if this x coefficient was? What would be really nice? What would help it cancel out? If it were a negative 10, right? Can we make the 2 a negative 10?
No.
I can't just change it to a negative 10, but what can I do? Multiply by what? 2 times what gives me negative 10? Okay, so if I multiply, now because I multiply, if I'm going to multiply this by negative 5, I got to multiply everything by negative 5 in that equation. If I do that, I'm going to alter the equation, but I'm going to alter it in a way where we can cancel out. So I'm going to take this equation right here, and I'm going to multiply every term by negative 5. Negative 5 times 2x gives us negative 10x. Negative 5 times 5y gives us negative 25y. Equals, and then negative 5 times negative 22, 110. So now, will that help me out? Can I solve it like I did example A now? You see what I had to do? I had to alter one of the equations. The top one had to be multiplied by negative 5 so that I could cancel the 10s out. All right, so now we're going to draw a line and we're going to add them down. 10x and negative 10x, we get 0. Those cancel.
Does it matter if it's x or y? Just get canceled.
It does not matter if it's x or y that gets canceled, no. 3y minus minus 25y, what do we get there? Negative 22y equals 22 plus 110 gives us 132. Divide both sides by negative 22. So our y coordinate is 132 divided by negative 22. Anybody know what that is?
7.
It's not 7.
Negative 6.
Negative 6.
I was close.
You were close. Negative 6. So we now have our y coordinate. I'm going to erase this to make room here. So we have our y coordinate. Now we can go back and find our x coordinate.
Basically, this is the exact same thing. All you have to do is multiply the whole equation by something to get an even.
To get opposites. Yeah.
Okay,
So then we can take this negative 6 and we can go plug it in somewhere. Where is the best place to plug it in? We can plug it in here, here, or here.
I'd say middle one.
I'd say top one.
Middle?
It's 2 votes for middle.
We'll do the middle. Why not? Okay.
Losers.
We'll do the middle. So we're going to plug in for y. We're going to plug negative 6 in. So over here we get 10x plus 3 times negative 6 equals 22. So now we solve this equation. We get 10x, 3 times negative 6, negative 18 equals 22. Add 18 to both sides. We get 10x equals 40. Divide both sides by 10. So x is?
Your coordinates are 4 and negative 6.
4. Yeah, and then we need to write it out. Our answers need to be written out in a coordinate point. So our x value is 4. The x comes first in your ordered pair, and then the negative 6. So this is your solution.
This one's probably the easiest by far.
I like it.
It depends on how the problem's set up. They won't all be set up where the x's and the y's and the equals and the numbers are all lined up. They won't always come out that nicely.
Yeah, but I mean, all you all you have to do in the end is solve an equation, pretty much.
All right, any questions on A or B? All right, let's look at letter C. Now, in this situation, we have to multiply both equations by something. Okay. We either work with the coefficients on the x or the coefficients on the y. Which coefficients are smaller? The y's or the x's? The y's. So it's, you might kind of want to start with the smaller one to keep your numbers small. So 2 and 3, my y coefficients, we got positive 2 on the top one, we got negative 3 on the bottom one. What are those both factors of? 6. Can I get them both to be 6 and negative 6? Okay. What would I have to multiply this top equation by to get 2 to be 6? By 3. How about the bottom one?
Why do you have to multiply both of them?
Because otherwise, see, there's nothing, if I only took one of them, there's nothing I can multiply 7 by to get 4, is there? And there's nothing I can multiply 4 by to get 7, so we have to do them both. Okay, so now, Eric said a while ago that this 2 might need to be negative. If it were positive on both of these, yes. But because we already have the negative sign and the positive sign, we don't need to worry about signs. In some cases, we will, though. So we're going to rewrite each of these equations. On the top one, we got 3 times 4x gives us 12x. 3 times 2y gives us 6y. Equals 3 times 14 gives us 42. On the second equation, we got 2 times 7x gives us 14x. 2 times negative 3y is negative 6y. 2 times negative 8, negative 16. So there are times where you will have to multiply both equations by something.
So wait, why is it the 3 and the 2 right there?
They're smaller numbers. They're smaller
So it
numbers.
doesn't really matter.
No, we could have done the 4 and 7.
But they're small.
We could have taken care of it with the 4 and 7. We could have multiplied, because they're both factors of 28. But then you have big numbers to
But then
do.
you also got a bigger.
Yeah, so,
Wait, so it has to be a fact, 2 numbers that are factors?
yeah, they'll be factors of something. They'll both be factors of the same number. Okay. Now, we're going to add these two equations. 12x and 14x gives us 26x. Our 6's cancel. 14 minus 16, not 14, I'm sorry. 42 minus 16 gives us 26. Divide both sides by 26. X equals 1.
Let's use the top one.
The top one? Okay.
Senora.
Take this x equals 1 and we'll put it right in here. Okay. So we have 4 times 1 plus 2y.
Whoa. Did you see all the color splash?
Okay, plus 2y equals 14. 4 times 1 is 4, so we get 4 plus 2y equals 14. Subtract 4 from both sides. 2y equals 10. Divide both sides by 2. And y equals 5. So our ordered pair then is 1, 5.
These are pretty simple.
All right, what I want you to do right now is I want you to go over to the back side of the paper. The back side of the paper, there's 3 of them that all I want you to do is set up. I just want you to get them set up. You don't have to solve them. But on the back side, letters A, B, and C, I just want you to get set up. I want you to do this part right here. Just this part.
But they're not all going to be that same thing, are they?
Huh?
They're not all going to be that exact same way to set up. They could be like A and B were too.
Yeah, they could be. Yeah, you may only have to multiply one of them. You're going to have to multiply at least one of the equations, though. So I want you to just set up A, B, and C.
Can we do 3 and 2 on all of them?
All right, so let's look at what you guys came up with on these practice setting up the problems. Letter A, what is one way some of you guys set it up? Caleb, what did you do?
You multiply the top one by 2 and multiply the bottom one by 7.
Multiply this one by 2 and this one by 7. That is correct. That is one way that can happen, because if you look at your y terms, 2 times negative 7 is negative 14. 7 times 2 is positive 14. That's one way. Did anybody do it differently?
I multiplied the top one by negative 4.
Okay. Nico multiplied. Is that what you did, Destiny?
Hey, those are both, that's bigger numbers there for now.
Either way will work. Either way will work. So on the top, if we multiply that by negative 4, then we will get then that will help us eliminate the x term. Because there's more than one way to do these. Both of those ways are fine. Okay, let's look at letter B. How did we set that one up?
Multiply the second one by 3.
Okay, multiply the second one by 3, Eric says. That'll work. Multiply this by 3, and then what do you get when you take 3 times negative 5? Don't you get negative 15? Then we'll cross that with this 15, right? Did anybody
You
do
could
it?
divide something and you just don't have to do multiplication.
You could divide everything by the same thing, yes. But that sometimes leads you to getting decimal or fractions. So you might make it harder on yourself, unless they're all divisible by something. If they were all even numbers, you could divide it by 2 or something. Yeah. Okay, what's another way somebody did? Dallas, what did you do? That will work as well. You can multiply the top
That's
one.
what I was gonna do, and then I switched it.
Yeah, either way works just fine. That will eliminate your x's, the other way eliminates your y's. So, all right, let's look at the last one and see how we did that one. Letter C, what's a suggestion? What'd somebody do?
Multiply the top line by 7, multiply the bottom one by 2.
Okay, multiply the top one by what?
7.
7, and multiply the bottom one by what?
-3.
-3. Yeah, one of those would have to be negative. We could have done the 7 negative and the 3 positive. That would work too. Because you got to have them cancel out. Nico, what did you do?
I divided the top one by 3 and the bottom one by 2.
Okay,
Easy there, cowboy.
you can do that. But what will happen is when you, if you divide everything by 3, that'll work on the top equation. You'll get whole numbers. But this one down here, if you divide by 2,
You get 7 divided
you're
by
going
2.
to get 7
that's
over
3
2. That's a fraction.
3.5.
So-
Not the number you want.
I mean, that works if you want to work with fractions. But that will be an acceptable way as well. Did anybody do anything with the 10 and 15? Eric, what did you do? You did something.
Multiply the top one by 2 and the bottom one by -3.
Yeah, will that work? Do you see how that'll work? Which one will that eliminate? X's or Y's? The X, because you'll get 2 times 15 gives you 30. -3 times 10 gives you -30. And that is how you get those set up. I think that's the hardest part. That's why I wanted to give you some practice problems on setting up. Thank you for watching.